Hello and welcome to chapter 3. Sorry I'm not here today. I am taking care of my elderly dad and running him around for medical appointments. And you are still responsible for learning. So I'd like you to take a few minutes and try the warm-up. Pause the video. Note the notation. It's the limit of, and then it has a function there. The limit as x approaches 2 of x squared minus c over x minus 5, that equals 7. That limit notation means plug in that x value, plug in 2 for x. So 2 squared minus c over 2 minus 5, which is negative 3. Cross multiply, and I get 4 minus c equals negative 21. Subtract 5, and I get c equals 25. We were able to find a value. Does that mean that the function is continuous at that value? Doesn't matter that we were able to fill things in, plugging in that 25, if we check at 5, the function factors, and this is a removable discontinuity, but it's not removed. So it's still a discontinuity at x equals 5, even though we were asking about x equals 2, you need to consider the whole function. I am trying to change the format of the class that makes you do more work in class. So today I am hoping that you guys can work through these problems in the textbook and we can work through any problems. Sorry, I can't be there today to help with that. But the homework tonight is on Delta Math, and it will give you immediate feedback. Check the solution, like click show solution or watch video, and hopefully you'll work through the problems. Okay, so all of chapter 3 is how to find derivatives. Which rate of change is slope? That's f prime of x. This is that limit definition of derivative that we did in chapter 2. So this is asking you to find the derivative at a specific point, like 4 or 5. So this indicates what is the slope at that exact value. Just giving you some notations. There are a bunch of ways to write the derivative. The most common one is f and a tick mark. That's called prime. F prime of x is the most common notation. But sometimes people write y prime. And it's nice and short, but it doesn't name what the rate of change is with respect to. Like, how is the area changing as we change the radius? How is the volume of water changing as the height of the water goes up in a cone? Something like that. It's better to have this bottom variable named. This is what's the derivative of a particular function with respect to x. And then this one would be the same thing, but they might say, what's the derivative of sine x, like that. So these are just notations, and they're all ways of expressing the same concept. Okay, here, the domain of the derivative can be smaller than the domain of the function itself. And if the derivative exists, we say that the function has a derivative or that it is differentiable at all of the x values where that derivative exists. And if on an AP question they tell you a function is differentiable at every point in its domain, it's calling it a differentiable function. Okay, so what is a derivative? If I ask you to graph the derivative of this thing up here, well, derivative is slope. So from 0 to 1, we went up 2 over 1. So I'm going to go to the height of 2, and I'm going to graph that slope. at this corner, what's the slope right at that corner? I don't have one, so I'm going to do an open circle. This next portion, we went up 1 over 3, so the slope is 1/3 for this time frame from 1 to 3. So from 1 to 3, the slope was 1/3, so that's what the derivative looks like. Over seconds 4 to 6, it was flat, there was no rate of change. It does have a slope, and it is 0. And then here we went down 3 and over 3, so the slope was -1 for those remaining pieces. 0 slope from 3 to 6, and then from 6 to 9 we went down 3 and over 3, so the slope there was -1. There you've graphed a derivative. Okay, this function. Is the function differentiable at 0? For x is 0 and bigger than 0, we graph the function y equals x. For all x values less than 0, we graph y equals -x. The slope over here is -1. On the right side of 0, the slope is +1. That these values of slope are different. Since the slopes on each side are different, on each side of 0, we cannot do the derivative at 0, so the function is not differentiable there. Here I want you to think about things. Take a few minutes with a partner and look at these functions and see if you can match up with the derivative on the other side. Some hints. Where is the slope positive? Where is the slope negative? Where is the slope 0? So this right here has a slope of 0. So the derivative needs to hit the x-axis there. So looking at these graphs of derivatives, ooh, this one hits 0 right there. This one does not. This one does not. This one kind of looks close, but it's in the wrong place. So to me, 5 looks like it matches up with E. So pause the video and see if you can match up the rest. Here are the answers. Check and see if you agree with them. Here on the right side, the slope is +1. So that's this piece of the graph. And on the other side, the slope is -1. That's this piece of the graph. And there's an open circle at 0 itself because there is no slope right at that corner. These are the textbook problems that I would like you and your partner to work through. So pause the video and give it a try. The equation of a line that I'd like you to get used to using is y minus the y value equals slope times x minus the x value. In here, they gave us the coordinate is 2, 3, and they gave us the slope is 5. So y minus the y value equals slope times x minus the x value. Stop there. That's the answer to part A. Normal line means perpendicular. The perpendicular slope of 5 is the negative reciprocal. So turn 5 upside down and change the sign. That's our slope. The normal line for this would be y minus the y value equals slope times x minus the x value. And stop there. Don't distribute, don't combine anything, leave it alone. The meaning of derivative is what's the slope. This line is, well, this equation is just a straight line. So what is the slope of that straight line? From geometry, you know it's the number that's multiplying the x. The slope here is 3. Okay, pause the video again and see if you can match up the equations. These are the derivatives. These are the functions. So this function has a 0 in all of these places. So looking on the other side, where do zeros hit? Here, 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 and here. If This is the function. This is its derivative. This one, the function, has a zero slope here, here, and here. The only place that happens are those places. And this is going to have a positive slope, so the function needs a positive y value there. This has a positive slope starting right there, so the function, the derivative, should have a positive slope there. So this is the function, and this is a graph of the derivative. This function only has a zero slope there. It's only going to cross once. Both of these hit zero, so let's see. This has a negative slope until then. So it needs to be below the x-axis. So those two match up. This last one, there's a zero slope there, and it's a positive slope the whole time. So the function should be positive the whole time. That's why those match up. Problem 16. If this is the graph, try and draw the derivative. It's going to be zero in those places. Between those two places, the derivative is going to be negative. It's continuous. It's going to do something like that. And then right here, it's a little bit positive, a little bit more positive, lots positive. Same on the other side, positive slope. That's what it should look like. Try this problem. Pause the video and give it a try. Graph the function's derivative. On the same graph, well, from here we went up 2 and over 4. So the slope is 1/2. From 0 to 1, we went down 1, 2, 3, 4, and over 1. So that's a slope of -4. Across here, we have 0 slope, which exists. It's not, does not exist. It's not undefined. It's just 0. And then from here, our slope went up 1, 2, 3, 4, and over 2. So the slope was 2. So the segments in pink are the derivative. This is asking, where is it not differentiable? All those places where there are corners. So at x equals 0, 1, and 4. And don't worry about the endpoints. So this is a bit reverse. Here's the derivative. And there's a coordinate. Graphing the function. Well, plot the information it told you. The original coordinate is 0, 0, and the slope there is -1. So this side is -1 until we get to a value of x equals 1. It tells us the function is continuous, so I need to color this in. And then after this, after x equals 1, the slope is now +2. So go up 1, 2 over 1. There's your graph. And then if there's any more time and patience in you, try going to this derivative match game and see if you can figure it out. And remember, there is homework on Delta Math tonight.